Okay, exam 2, here we go. Question 1 asks to explain Boyle's law and Dalton's law and how it's related to gas exchange in our bodies. So here is my visual of Boyle's law, which basically states that volume and pressure are inversely related. So if volume increases, pressure would decrease. If pressure increases, volume would decrease. That's what inversely related means. And so how it relates to gas exchange and inspiration and expiration is, this is a picture of your lungs, okay? It's really good. And then this is the atmosphere. So let's say the atmosphere is 760 millimeters of mercury. That's its pressure, the pressure of the atmosphere. When we go to inhale, our diaphragm contracts and our lungs expand. And when our lungs expand, the volume gets bigger, which means the pressure decreases. So the pressure inside of our lungs is going to be less than the 760. So like, for example, just say it's 755. So because of that, because the pressure is less here, the air is going to flow from the atmosphere into our lungs because it wants to even itself out. When we go to exhale, it's the same thing. Our diaphragm is relaxing, so the volume in our lungs decreases, which means the pressure increases. So now the pressure in our lungs is greater than the pressure in the atmosphere, so the air is going to flow out back into the atmosphere. And that's Boyle's law. Now, for Dalton's law states that the pressure of something is the sum of all the different pressures in it. So you can see here in my visual, like this section right here is like much more condensed. It's a little less dense here, more dense, but the total pressure in this space is the sum of all of these combined. Why do we care about that? How does it affect gas exchange in our bodies? Partial pressure is the easy answer. So the partial pressure of oxygen would be like, how much pressure is oxygen specifically exerting into this space? So like, let's say right here, that's oxygen. We would calculate how much percent that is. And so like, for example, the partial pressure of oxygen in our atmosphere at sea level, there's about 20% oxygen. So you would take 760, which is the millimeters of mercury, and then multiply that by 0.2%, or 0.2, because that's 20%, and that would give you 159 partial pressure of oxygen. And you can do that for carbon dioxide and nitrogen, and that's how it relates to our bodies, because it's very important when it comes to the flow of oxygen throughout our bodies. The partial pressure of oxygen is going to decrease as we go through the whole cycle, but we will get into that, and that is the answer to question 1.